Welcome you all to the Research Part YouTube channel. I am Dr. V. Chandra and this is part second for analog and linear electronic circuits. So we are running in unit first, that is single and multi-stage amplifier. So if you remember, in our previous session, we have discussed the bipolar linear amplifier, load line analysis and a small signal models. So there we have discussed how can we draw the equivalent model for our BJT based amplifier for our AC analysis. So now we are going to utilize the same equivalent circuits in order to solve the analysis of common emitter or the common base and the common collector based amplifier. So let us start from the common emitter circuits. So here is the common emitter circuits and in the left side and the corresponding equivalent hybrid bi-model based circuits. So first of all, how can we draw the equivalent model? So if you remember that your transistor, that is your BJT, can be replaced by the R pi and the current source of beta IB. So this is the one of the most important thing that you must have to remember. If you do not remember, please go to the part first. This is now we are going to use it regularly, and this is a very simple. Now once you will draw the equivalent circuit first by using the hybrid equivalent model, then you can add the other resistance in the input terminal as well as you can add in the right input output terminal. So I have redrawn the equivalent circuit so that it will be easier for us to find out the gain. So what is our primary objective during the analysis of common emitter? So the primary objective is to find out the gain, that is our voltage gain, means V out by V in. So first we will try to find out the V out and then V in, then we can finally take the ratio of output voltage to the input voltage in order to find out the gain, that is our objective. So first let's start to calculate the V out. So in order to find out the V out, here first let's try to find out the V out. So since current is passing through your RC is equal to your beta IB, since we are going to calculate the V out across the RC terminal. So the finally your V out will be beta IB into RC, I into R. Then let's find out the V in. So how much will it be? So just check it. Your IV current which is passing through the R pi and then beta IB plus beta IB into RE, that is passing through your RE terminal. So totally V in will be this one, IB R pi plus IB B plus beta IB into RA. From here just divide it by IB and we'll get the RIB. And your Ri, that is input resistance, will be equal to the R1 parallel to R2 parallel to RIB finally. So RIB, once we will get this RIB, that is the resistance across the base terminal, then since R1 and R2 are parallel to both this base terminal, so finally your resistance will be R1 parallel to R2 parallel to RIB. By using this, now we can find out the voltage input, that with the help of the voltage divider rule we can find the voltage in across the Ri terminal. So Ri, since the total resistance is Ri plus Rs, Rs is the resistance which is connected with the source. So now, so across voltage across Ri will be equal to Ri divided by Ri plus Rs, that is total resistance into the Vs. So now by using these equations, that is V in and the V out, we can calculate the gain, that will be equal to the finally minus of RC divided by RE approximate value. So finally we got the voltage gain, that is our objective to calculate. Now we can also solve the different types of the emitter, common emitter based circuit with the same technique. So technique will be same, means first draw the equivalent circuit, then find out the current output, then the input current, then the voltage output, voltage current, and then finally find out the gain. This is the same process. So also you can try some more exercises to calculate. Now let's move to the common collector circuits. So here is the circuits left one. You can see here collector is common, and now we are going to collect the output across the emitter terminal. Since collector is common, so we are going to utilize the emitter terminal. That is, we are going to collect the output voltage across the emitter, the RE. And right side is showing the hybrid pi model equivalent circuit corresponding to the common collector. So again, your transistor is being replaced by R pi and current source of beta IV. Again, R naught is just in parallel with the beta IV, and R naught will be very high, and so RE having the resistance with the emitter terminals, so just include them, and the input parallel input resistance will be parallel R1 parallel to R2. So finally, here is the equivalent circuit using the hybrid pi model. Just check in the right top. So just look carefully. The R pi is there, beta IV is there, and R naught and RE in parallel with the beta IV towards the output terminal, and the input terminals R1 and R2 are parallel, and then the RS in series with that. So first, again, our target is to calculate the gain, that is V out and V in. So let's start to find out the V out. So in order to find out the V out, first let's find out the I naught, I output, I out. So how much will it be? So I out will be equal to beta IB plus beta IB. Why? Because IB is passing through the R pi, that is the base terminal, and then the beta IB, which is passing through the collector terminal. So totally current will be the sum of both. So output voltage will be I into R. So R output is R naught, R out parallel to RE. So that will be the voltage output. Now voltage input will be equal to I into R. Here R will be the R pi plus 1 plus beta into R naught parallel to RE, because the total current which is passing through the output here. So with the help of the current IB, we can also find out the RIB, that is the resistance across the base terminal. So the resistance will be here R pi plus 1 plus beta R naught into RE. So now again, with the help of voltage divider rule, you can find out the V in, that will be equal to Ri divided by Ri plus Rs into Vs. Ri will be same, that is the R1 parallel to R2 parallel to Rib. Now finally calculate the gain of this common collector circuit, that will be equal to V out by Vs, and put the values and get the value of the gain. One more thing that we can discuss it here for the common collector circuits, that is the current gain. So for the previous circuit, that is for the common emitter, or we can also calculate the current gain. But since this current gain is important for this common collector circuit, so let's discuss it here. So the process will be the same, just find out the output current and the input current, and then just divide it to calculate the current gain. So let's start. So first IB will be equal to your R1 parallel to R2 divided by R1 parallel to R2 plus RIB into II, and your output current will be equal to 1 plus beta into IB. Just you can find it from the equivalent circuit itself, that I have shown it in the previous slides, and then IE, just find out the IE, which will be equal to the I output into again the form of the KCL law. We can get it R naught divided by R naught plus RE. Then in order to get the AI, that is current gain, you can just make it divide IE divided by I. Finally you will get the current gain, which will be equal to 1 plus beta. Lastly, we are going to talk about the common base amplifier. So just check the circuits. Here base is common, and so we are going to collect the output across the collector terminal, and we'll supply the input terminal across the emitter terminal. So again, we will draw the equivalent circuit, and then we'll solve the circuit. So in order to draw the equivalent circuit by using hybrid pi model, again just replace your transistor by R pi and along with the current source of GM V5. So just check the equivalent circuit. And by using the equivalent circuit, again we are our target is to calculate the voltage gain and the current gain. So let's solve. So in order to get the voltage gain, let's first find out the output voltage, that will be equal to minus of Gm V pi, that is your current, and the voltage, the resistance, that is RC parallel to RL. Now again use your KCL in the right side loop and then write down to find out the V pi, and find out the V pi in terms of the Vs, so that we can calculate the gain, that is AV, and finally you will get the AV, that is again will be equal to Gm into RC parallel to RL. Similarly, we can also calculate the current gain. So use the KCL equations to find out the I out and I in, and you can get the gain and the current gain, which will be equal to the alpha. So since this session is getting longer, so I'm not including the multi-stage amplifier. So I will include in the next part, that is part third. We'll start from the multi-stage amplifier, where we will discuss the cascade and Darlington type of the amplifier. Multi-stage means simply here whatever we have discussed in this session, it contains only one stage of the BJT based amplifier, but in multi-stage we are going to add two or more than two transistors to make the multi-stage amplifier. So based on their design structures, we can add in the series or the in the parallel. So if it will be in series, that will be called as the cascade. If we'll add in the parallel, then it will called as the cascade type of the amplifier. So we'll discuss it all those things in the next slides, the next session. So also will include the low frequency response of the BJT amplifier along with the high frequency response of the BJT amplifier. So thank you for listening me. If you have any questions, please drop your comment. Thank you.